Welcome back to another episode of Mr. A's Geometry Podcast. I'm glad you tuned in. Today we're going to look at inequality proofs. So the difference between an inequality proof and a regular proof that we've been doing is that normally we're trying to prove two things are congruent. Two triangles are congruent, two segments are congruent, and so forth. With inequality proofs, we're trying to prove that two things are different. So that something is bigger than something else, or something is smaller than something else, not equal to. So the mechanics are essentially the same as they are with any regular proof, except instead of congruent statements, we have inequalities, either less than or greater than. The other thing you need to be careful of is since you're dealing with inequalities, you're going to be dealing with measurements, either lengths of segments or measures of angles. So you have to be careful to convert things into measurements using equals and not equal signs. So in this proof, what do we have? AE greater than BD, AF equal to BF. So just like any other proof, we want to mark up our picture. Well, we can't put AF equal to BF in the picture, but since they're equal, we know they're congruent. So we can mark them that way. This way we can just see what's going on. So we'll go over here, AF congruent to BF. And right away you should see something in that picture. What kind of a shape do you see? Isosceles triangle, right? AFB. So you should know right off the bat that in case you need it, you're going to have congruent angles down here. Okay. Now I don't know if we're going to need that yet. Let's see what goes on in this proof. So we have these two segments equal, which means they're congruent. And then we have AE larger than BD, greater than. So it's difficult to mark greater than. What you can use is a plus or a minus if you want to in your picture. So you can say AE, this whole piece, right, is greater than BD, this whole piece. So if you like, you can give a line and say AE, that one's bigger. DB, that one is smaller. Okay? So we have one piece that's bigger, one piece that's smaller. We'd like to say something about FE being greater than FD. This piece being larger than this piece, FD. Well, if you look at this problem, you should get a feeling about what kind of a proof this is. If these were equal signs, right, if it was AE congruent to BD, AF congruent to BF, and prove FE congruent to FD, then you should know right away what kind of problem this is. It would be subtraction, right? You're given a statement about large pieces, a statement about small pieces, and you want the other small pieces. No different here. This is a subtraction problem. We have a large piece, larger than the other large piece. We have two smaller pieces that are congruent, and what we want to say is that the other pieces are unequal in size. FE is larger than DF. So we're going to set this up just like any other subtraction problem. Well, in subtraction, of course, you need to start with a partition step. What are we going to partition? Well, we're going to partition our large pieces, AE and BD. Now, since we're working with measurements, we're not going to use congruent segments equal to sum of congruent segments. We're going to use measurements. So we'll say in step 2 that AE, the length, is equal to AF plus FE. And we will also say that BD, the length, is equal to BF plus FD. That's a partition step like any other partition step. So since this is essentially a subtraction problem, we're going to proceed just like we would. In the next step, we're going to do a substitution. We're going to take what we had about the large pieces, AE larger than BD, we're going to rewrite it. But we're going to do a substitution. Instead of AE, we're going to substitute AF plus FE. And instead of BD, we're going to substitute BF plus FD. So it's going to go in just the way it is here. AE becomes AF plus FE. And all we're doing is swapping out, so the greater than sign stays the same. Greater than BD, which is BF plus FD. Now remember, since this is an inequality that you're substituting with, you're not using substitution postulate, you're using substitution of inequalities. So make sure you tell me that because they're not the same. And like regular substitution, you're going to tell me what steps you're using. Or we're substituting step 1 and step 2. So please tell me step 1, step 2. Okay? Well, so if we're doing subtraction, first we do partition, then we substitute, then we subtract. As long as you have something to subtract. So think about it. What are you going to take away from this side? Well, you want FE, so you want to get rid of this AF, right? And on the right-hand side, you want FD, which means you're going to want to get rid of BF. So do you have a statement that says AF is equal to BF? Sure you do. It's up here. So you've got a choice. You can leave it up there and just go ahead and do your subtraction, or if you want to be careful, go ahead and write it again. So give yourself a step 4 and say AF is equal to BF. My reason is still given. And now you're very nicely set up for your subtraction. So you're just going to do it. If we take this line away from this line, it's pretty clear what happens. The AFs cancel out. You get FE over here. Greater than. Here the BFs cancel out. You get FD. That's exactly what we're looking for. My reason is subtraction. Of inequalities, and like any subtraction, you're going to tell me what steps. So in my proof, that's steps 3 and 4. That's it. That's an example of a subtraction inequality proof. The only difference here is that instead of being told things are equal, we're told that something is greater than the other. And so we just proceed like you would any other proof, but at the end, instead of a statement of congruence or equality, we have a statement of inequality. So, if you have any questions on this, drop me an email or ask me in class. Thanks for watching as always, and stay tuned for the next inequality proof, which will take it a little bit further.